A bicycle rim has a diameter of 0.65 meters. Okay? And it's a diameter, not radius. So I'm going to underline that just so I keep an eye on it. Try not to forget it. And a moment of inertia measures about a centimeter of that. What is the mass of the rim? Okay, so for this one, we need to know the idea of moment of inertia is the angular equivalent of mass. A mass is an object's resistance to acceleration, and moment of inertia is an object's resistance or opposition to rotation. So you should be comfortable with the idea of force equals ma, F equals ma, Newton's second law. The angular equivalent is torque equals I alpha, where I is moment of inertia and alpha is angular acceleration. And we're going to use the formula to find moment of inertia for a rim, a hoop, and that's going to be mr squared. So yes, and that's just based on the geometry of the shape. And that's just something we look up. So for example, we can look up on Wikipedia, we have lists of moments of inertia, and this is basically just geometry and math to figure it out. Use the idea that a particle is mr squared, you expand that using math and integrals, and you can get other shapes. So the shape we're going to work with is, do they have a hoop? I assume they have a hoop. A circular loop, mr squared, which is the same idea as a point. So not too bad, we can do that. So mr squared, rearranging this, we get m equals I over r squared, which I'm going to rewrite as, I'm going to say that r equals diameter over 2, because we're given diameter. And so we get I over d over 2 squared. And normally I would do this using a calculator, but I don't want to because it's easier not to. And this can get a little bit complicated with the numbers. So I'm just going to use Wolfram. And so for Wolfram, it's going to be 0.25, which is in SI units. So it's got kilograms to square meters, divided by quantity 0.65 over 2 squared. And the nice thing about Wolfram is I can look at it and make sure that it looks correct. So 0.25 or 0.65 over 2 squared, because they give us diameter, we want radius, and that gives us 2.37. 2.37. So the mass is going to be 2.37, and the units for this, it's just going to be kilograms. Oh, bam. Yeah, that wasn't too bad. I think we'll go with that one. So that's how we do that one. That's just using the definition of moment of inertia. Hope that helped. See you next time.